notes B7B. Take a minute and set up your page, and remember, if you need to pause this for any reason, then go ahead and do that. So we're doing the last page of the notes on Evolution 1, and this is B7B. Examine scientific explanations. So examine scientific explanations of abrupt appearance. Abrupt means all of a sudden. Not slowly easing into something, but just all of a sudden it shows up. So abrupt appearance. And stasis. Stasis means the opposite of that. Stasis means it's not really changing much at all. So explain or examine scientific explanations of abrupt appearance and stasis in the fossil record. So we're going to look at the fossil record and look at how those fossils show up. In the next unit on the evolutionary theory, we're going to talk about how evolution works. So on this one, we're still talking about analyzing and evaluating the evidence of common ancestry. So what's our evidence for evolution? And then examine the fossil evidence is one of those big deals. Examine how it can show up all of a sudden with fossils and changes, or how it shows up slowly over time. So again, the first thing I want you to know is gradualism. And gradualism is what Darwin was all about. So gradualism in the fossil record, that's what Darwin said. He said, hey, things show up or things evolve slowly over time. So gradualism is the big, big, big deal with Darwin. So right here, you can put Darwin at the top of this. So gradualism, that's a big, big deal. This was the very first whole concept of the evolutionary theory, gradualism. And gradualism says that evolution is mostly a long, slow process. So it's mostly a long, slow process. Come in. And the bags are you getting the bags?
Yes.
Yep. And if you'll make sure the door doesn't close behind you, then you can just come in and get the rest of them, okay? So it's a long, slow process made of tiny changes. Thank you, guys. Many of the changes are not noticeable. They're such tiny changes. Until you see the before and the after. And I'm going to put that in quotation marks, before and after. So the changes happen so slowly that you don't really notice it. It's like you looking at yourself in the mirror every day. You don't notice the change on a daily basis, but then when you look at a picture of yourself from the beginning of the school year and a picture of yourself at the end of the school year, you notice, oh my gosh, I have changed some. So it's kind of a before and after when you talk about that pictures. So when you look at this, gradualism is saying, hey, there are just tiny little changes. Now keep in mind, when we're talking about these fossils, we're still talking about thousands and thousands of years. So there's a layer of dirt with fossils in it, and then the next layer of dirt, which was laid down, thousands of years later, the next layer of dirt on top of that has its fossils, and they're close to it. They're similar to each other, but they're not exactly the same. And then the next layer on top of that has another layer of fossils. And again, you see little bitty tiny changes as you go through, but mostly nothing big until you start comparing the original fossils with the end fossils. And then you realize, oh my gosh, there's a massive change. It's a new substance there. Okay? Now, I just said something about fossils being in layers of rock. Fossils are the same age as the rock that they're found in. That just makes sense, doesn't it? Fossils are the same age as of whatever rock they're found in. So if you go out to Palo Duro Canyon, you can see layers of rock. You guys, have you been out to Palo Duro Canyon, you know this. You've seen different layers of rock. Different layers of rock are laid down at different times, and so whatever rock layer that fossil's in, that's how old the fossil is. Now, besides gradualism, a few years later, quite a few years later, another guy came along and said, but what happens when you see one layer, you've got this fossil, and then the next layer, you can tell it's got this, it's a similar thing, but man, it's a big change. And so the next thing we talk about is punctuated evolution. In the fossil record. Yes. 10. Mm-hmm. Thank you. And punctuated evolution, they also call it punctuated equilibrium, so sometimes you might see it like that. This is when you have long periods of no change in the fossil record. So you have layer after layer of the same kind of fossil. And that's called stasis pretty much, and then it's punctuated, or all of a sudden there's this short periods of rapid change. So that's where they get the name for it, punctuated, or all of a sudden it has short periods of rapid change. So it's punctuated by short periods of rapid change. So when we talk about these two words, a lot of times this we talk about, here's our punctuated or abrupt appearance. There's abrupt. And then a lot of times what we call this is stasis. We refer to it as stasis. It's not staying the exact same. And so this matches with our words that are right up here. Abrupt appearance and stasis. Stasis typically means it's standing steady. It's staying the same. When we talk about stasis, we say it seems to look like it stays the same, not a big change at all, or there's very little change in it. So when I come down here and look at this, we're going to say stasis in the fossil record equals little or no change in fossils in different rock layers. So there's very little change or no change a lot of times. And then the abrupt appearance in the fossil record, and I'm going to try and be consistent in how I'm saying this. Abrupt appearance in the fossil record is when the fossils significantly change from one rock layer to the next. So they change, obviously, from one rock layer to the next. And maybe it's more than one rock layer. That's a scribble. Here, let me white it out. Maybe I can white it out. Okay, so sometimes it can happen repeatedly. Like there are several rock layers, and you can say, "Oh my gosh, I can see an obvious change every single time, and in 3 rock layers right in a row or whatever." So sometimes you see stuff like that. Sometimes it's just so slow and gradual that you don't really see it going on. Now, the only other word that I'm going to put in here for you guys is speciation. So when you build up enough changes, then you go back and you realize that, hey, this latest organism that's been evolved could not mate and have offspring with the original one. And when we have speciation, what that means is a new species is created. Remember, if they're in the same species, they can mate and have offspring. Similar organisms that can mate and have viable, that means normal, healthy offspring, and have viable, that they can also mate and have offspring. So if they're in the same species, they can mate and have offspring. But as you go through here and you have this change in the fossil record, the fossils that you find latest would not have been able to mate and have offspring with the fossils that you found earliest. Sometimes it takes several layers for that to happen. Like the first fossil down the lowest layer could probably mate with the ones above it, and those could maybe mate with the ones above that. But as you get farther and farther away, you realize that there are so many changes that have occurred that last fossil couldn't have mated with the original one and done anything. Now, the phylogenetic tree, I'm bringing this up again. Those phylogenetic trees, or diagrams, they're used to show the relationships among fossils. So they look at these relationships, they look at these fossils, and they try to connect them. Do we have fossils for every organism? No. Not even close. If you look at the number of organisms that have been alive on the planet since life happened, you realize that the appearance of fossils, or the production of fossils, is, oh my gosh, it's so tiny. So we really don't have a lot of fossils to work with, but what we have, we try and organize and group. Just like we do with animals today, we try and group them into like things together. That's one of the big things that science is we try and group things together that are like. And so in that way, we can understand them more. We can say, hey, well, what is this used for? What is this good for? What can we use this for? What can we look at this? How are they alike? How are they unalike?